Okay, in this proof we know that segment AC is congruent to segment CB, so I'm going to go ahead and go and mark those with tick marks in my picture. And we know that D is the midpoint of AB, so that is our given. Alright, so since we know that D is the midpoint of AB, that means that segment AD is going to be congruent to segment DB. I'm going to go mark those in my picture. So AD is congruent to DB because D is the midpoint, so that is the definition of midpoint. And then I see that these two triangles share a side, they're touching. So whenever two triangles share a side, that is the reflexive property. So I'm going to say CD, the side that they share, is congruent to itself. CD is congruent to CD. And that is the reflexive property. And I'm going to go mark that in my picture. And so now I see, oh my gosh, these two triangles are going to be congruent to each other. So triangle ADC is going to be congruent to triangle BDC. ADC is congruent to BDC by side, side, side. And now, I haven't said anything about any of the angles. I don't know any of the angles in this triangle are congruent. And any of the angles in these triangles are congruent. But now that I've proven that the whole entire triangle is congruent to this whole entire triangle, I can prove that any of the corresponding angles are also going to be congruent. So in our proof statement, we're trying to prove that angle ACD is congruent to angle BCD. A, C, D, C is the last letter. B, C, D, C is the last letter. Those two angles are corresponding parts of these two triangles, and because we have proven that those two triangles are congruent, we can now use CPCTC. So I can say angle ACD is congruent to angle BCD. Because now that I've proven that the two triangles are congruent, now CPCTC, I can use it to prove that any of the other corresponding parts are also going to be congruent to each other. So remember, I can only use CPCTC after I have proven the triangles are congruent by one of my shortcuts.